Hi students, Miss Slyman here, and I'm going to talk to you about Lesson 51, Trigonometric Identities. So here's some identities we already know, our reciprocal identities. Cosecant is 1 over sine. You can also think of this one as hypotenuse over opposite. Secant is 1 over cosine, which is the reciprocal of cosine, so hypotenuse over adjacent. And cotan is 1 over tan theta, which I can think of as adjacent over opposite. So all of these are ratios, and we have quotient identities as well. And both of these you already know, that tan theta is sine over cosine, and similarly cotan is a reciprocal, cosine over sine. Our Pythagorean identity, this is the one we know, but let's think about how I could get this one or this one. If I take my Pythagorean identity and divide through by sine squared, so if I divide everything by sine squared theta, sine squared theta, sine squared theta, well, of course, this one cancels and makes 1. Cosine over sine is cotan. 1 over sine is cosecant, so 1 over sine squared, cosecant squared. Cos squared over sine squared, well, that's the same as cos over sine, all squared. So I get cotan squared. And then if I had done the other way and divided through by cosine, then sine squared over cosine squared, tan squared, cos squared over cos squared, 1 over cos squared, secant squared. So with the Pythagorean identities, I only have this one memorized because I know that I can always make these two really quickly. Similar with the cofunction identities, I don't have any of these memorized because I can quickly draw a right triangle. And so in my right triangle, I think in radians because I'm a sophisticated mathematician. So if this angle is pi over 2, all 3 angles add up to pi. So this one must be pi over 2 minus theta, if this one is theta. So if this is pi over 2, these two also add up to make pi over 2. Okay, so looking at this, I could say that sine theta is b over a. Well, b over a is also cosine of this angle. So notice we've got sine theta is equal to cosine of pi over 2 minus theta. Also, I could say cosine of this angle, so cosine theta is c over a. Well, that's the same as sine of this angle, c over a. So sine of pi over 2 minus theta is cos theta. And I could keep going with all of my identities. Again, I have none of these memorized. I always just think of a right triangle to come up with them. Our last set of identities, last set of identities are the even-odd identities, so even-odd functions. So remember, if I have an even function, the definition of that is that f of negative x equals f of x. So this is a reflection across the y-axis. Well, if I look at my 3 functions, sine, cosine, tan, this one, if I reflect it across the y-axis, it looks the same. So cosine is an even function. Similarly, secant, the reciprocal of this, also even. Odd functions were when f of negative x was equal to negative f of x. These reflected through the origin. So thinking about sine, if I take this and reflect it through the origin, here's the picture I get. Sine is an odd function. So if I see sine of negative theta, I can rewrite it as negative sine theta. Similarly, if I take this bit of tan and reflect it through the origin, I get this bit. Tan is also an odd function. So all of these identities are really helpful in simplifying problems, and that's what we're going to look at in our next set of videos.